Okay, guys, for the next lesson that we are looking at solving and graphing multi-step inequalities. Okay, so these multi-step inequalities are obviously going to require a little bit more work than the ones we've been doing, but it shouldn't be anything that's too new to us as far as concepts in algebra go. Okay, for number one, I have -3 is less than or equal to -5 plus 3n minus 2n. Okay, I can start off right away by combining my like terms. 3n and -2n are like terms. 3n minus 2n is going to give me 1n. Remember, when you just see a variable, it's not common practice to write the 1 in front of the variable, but it's always assumed to be there. Okay, my next step now is to subtract that n from both sides. The reason I'm doing this is because we are used to seeing the variable on the left side of the inequality, okay? So there's no point in breaking that habit that we've created. So once I do that, I know that I can't combine -3 and n because they're not like terms, so I can just write them out next to each other. -n minus 3 is less than or equal to -5, okay? Now that I have all my variables on the left side, I can move everything else away from it. I can isolate it. Right? That's what we've been calling this step. We isolate the variable. Okay, I do that by adding 3 to both sides. That would leave me with -n is less than or equal to -2. Now my n is not completely isolated yet. There's still a negative sign there. I got to get rid of that. Okay, I can do that by dividing by -1. Now hopefully we remember our rule that we can't forget. Anytime I multiply or divide by a negative number, I need to flip the inequality. So I go from less than or equal to greater than or equal to. I get n is greater than or equal to +2. So if I graph that, remember my greater than or equal to, that's a closed circle at 2. Okay, so if I were to graph this, our PowerPoint must not have it, I would number out my number line. Let's say 2 is right here. Okay, I would put a closed circle above it, and I would want everything greater than, which would be everything to the right. Okay, so your number lines can look a little different since we don't have it done here. You can put 0 here, you can put 0 there. As long as you can fit 2 on there and then show that you want all the values greater than or equal to it, you're good. Okay, on the next one. Okay, I have -x plus 5 plus 5x is greater than 3. Again, I want to start by seeing if I have like terms I can simplify, and of course I do. I have a -x and a positive 5x. I can combine those to give me 4x. So I would have 5 plus 4x is greater than 3. I now can subtract 5 from both sides because my variable is on the left side already. Okay, so I can work on isolating it. When I subtract 5 from both sides, I get 4x is greater than -2. Okay, now my x is almost completely isolated. We have one more step to take. Okay, I would have dividing by 4 as my next step. Okay, I'm not dividing by a negative number though, so there's no need. I repeat, there is no need to flip this inequality because I'm not dividing by a negative number. It's only when it's a negative number. I get x is greater than -1/2. Okay, when I have x is greater than -1/2, what I want to look at is the number line. We might have to number it a little differently. Okay, if you want to go by half point increments on your number line instead of full point increments, that's fine. Okay, so we can do that. That is an option. Okay, so if I have x is greater than -1/2 and this is 0, this would be -1/2. I want the values greater than it, so I would have an open circle at 1/2, and I would be going to the right. Okay, for number 3, I have negative parentheses 1 minus 7p, close parentheses, is greater than 2p plus 19. Okay, I can distribute this -1 to everything inside the parentheses. I would get -1 plus 7p is greater than 2p plus 19. Okay, I then need to get my variables on the left side of the inequality. I do that by subtracting 2p from both sides. I would get -1 plus 5p is greater than 19. Now I can work on isolating this variable. I add 1 to both sides. I get 5p is greater than 20. And now I can divide by 5. Again, there's no need to flip this inequality on this one, guys, because I'm dividing by a positive number. I only flip it when I'm multiplying or dividing by a negative number. Okay, So I get p is greater than 4. So here I make my number line 0, 1, 2, 3, 4. Okay, and I want the values greater than it, so it would be an open circle. I'd put an open circle over 4, and I'd show the values to the right of that. Okay. For number 4, I have negative 38 minus 7b is greater than 4 times 1 minus 7b. Okay, there's kind of a lot going on with this one. Again, nothing's going to change here. I'm still going to distribute this. So 4 times 1 is 4. 4 times negative 7b is negative 28b. I didn't do anything with the left side, so I'm not going to change it. Okay. Now that I have both sides simplified, I want to move my variables to the left. I do that by adding 28b to both sides. And 28b minus 7b is 21b. So I get negative 38 plus 21b is greater than 4. I then want to add 38. Now I'm working on that isolation step, right? I want to isolate this variable. 38 plus 4 is 42. So I get 21b is greater than 42. I then can divide both sides by 21. And 42 divided by 21 is just 2. So I have b is greater than 2. Okay? So I would number this number line out, and I would put an open circle over 2, and I would show all of the values greater than that. Okay? For number 5, I have 15 minus 3n is greater than 3 times n minus 6. Again, first thing I want to do is distribute right here. When I do that, I end up with 15 minus 3n is greater than 3n minus 18. Okay, now that both sides are simplified, I want to move my variables to the left. I do that by subtracting 3n from both sides. I'm going to move this one over here, the right side to the left side. Well, negative 3n minus 3n is negative 6n. So I have 15 minus 6n is greater than negative 18. Now I'm going to isolate this variable. Okay, once I have my variable moved to the left side and there's no other variables remaining, they're all on the left and combined, I can work on isolating. Okay, so I'm going to subtract 15 from both sides. Negative 18 minus 15 is negative 33. I get negative 6n is greater than negative 33. I divide by negative 6, and again, this should be our rule that we always remember, right? Am I dividing by a negative number? Big time. Okay, so I need to flip the inequality. So this greater than is going to change to a less than. So I have n is less than 11 halves. Now this one maybe could get a little tricky to graph. Okay, what is 11 halves as a decimal? If we take 11 divided by 2 in our calculators, we should get 5.5. Okay, so if I wanted to here, I could number these out 0, 1, 2, 3, 4, 5, 6, 7. I could still number them by whole numbers. I just need to find the halfway point between 5 and 6. And at that halfway point, or about that halfway point, I would put an open circle because it's less than. And now I want less than, so it would be going to the left. Okay. Hopefully that makes sense for us. Okay. Sometimes these halves can trip us up. No one's going to look at this and say, oh, well, you're so far off from being halfway. Just get it as close as you can. Okay. To that 5.5 mark. For the last one for today, we have solve and graph the inequality just like we've been doing. I have negative 3 plus 2 times k minus 8 is greater than 2k minus 20. I'm going to distribute to start. I get negative 3 plus 2k minus 16 is greater than 2k minus 20. Okay. Now that I have the left side simplified and the right side simplified, I can move my variable. Oh, excuse me, the left side was not simplified. I was a little bit ahead of myself there. Sorry, guys. Okay, I can combine negative 3 and negative 16 to get negative 19. I would have 2k minus 19 is greater than 2k minus 20. Now that both sides are simplified, now I can work on moving my variables to the left. I move a positive 2k from the right to the left by subtracting. Okay, I get 2k minus 2k. What's going to happen here with my variables, guys? Hopefully, we're saying they're going to cancel out. And what happens when we get variables that are canceled out in an inequality? It's going to be a certain kind of solution. Hopefully you're saying unusual solution, okay? Unusual solution. Remember, my two unusual solutions are if it's a true statement, it's all real numbers. If it's a false statement, it's no solution. So what I'm left with here is negative 19 is greater than negative 20. Again, the negative signs can be a little tricky. Is negative 19 further right on the number line than negative 20 is? Always think of a number line. Is negative 19 more right on a number line than negative 20? When we think of it that way, hopefully we can say, yes, it is. So therefore, it is greater than, okay? Which means it is a true statement, okay? It is a true statement, and it's all real numbers. Remember, my graph for all real numbers would be a double-sided arrow that goes the length of this number line, okay? So that's it for your examples today. And the joke of the day is, what do baby parabolas drink? Remember, parabolas are what we just got tested on last unit, our graphs. It is quadratic formula, okay? Hopefully you got a little chuckle out of that. I'm sure everyone did, okay? That's it for today's lesson, guys. Let us know if you have any questions.